Hi everyone. So today we're continuing our use of logs, and we're going to go into something called natural log, as well as our exponential e value. Okay. So here we go. Let's talk about logs in general. A log solves for exponents. That's something that we emphasized before. The whole reason why we have logs is they help us solve for exponents. And if I write something like 3 to the x equals to 9, we all know the answers too. Come on, we know the answers too. 3 squared is 9. But that's us guessing the answer. But for us to do this algebraically, we have an identity here. Well, this isn't algebraic, this is just straight identity. Is that we say, you know what, log solve for exponents. So if I write log solve for exponents, and the exponent here is an x. Now we write a little number here, and that's called the base, and then we write the answer. So every place in a log means something. So the base here is 3, and the answer is 9. And this is how we set up a log. If you want to use an identity, not algebraically, just using identity, we can rewrite an exponent into a log so that we can type this in a calculator. Now on the calculator, we mentioned before, you would type this as log 9 divided by log 3, depending if you have an old calculator. If you have a nicer calculator, you would type it as exactly as you see it. Like there would be 2 boxes in your calculator. Okay. So we have this idea of this calculator, how to type this on the calculator. And if you want to try it right now, if you type log 9 divided by log 3, you should end up with 3? No, you end up with 2, right? X equals to 2. Circle of logs, 3 squared equals to 9. If you remember my circle of log joke, 3 to the exponent is 9. Circle of logs, log base 3 of 9 is equal to 2. Circle of logs, 3 squared is 9. Why? Because log solve for exponents, so the answer to any log is that exponent of the base, and the base here is 3. So now there are a lot of different logs, and as you can see, we have log base 3 here. We had something called common log, and that is, if you just see log with nothing here, that's an invisible 10. Invisible 10. So if I write 100, what exponent of 10 would give you 100? Log solve for exponents, that exponent would have been 2. What if I wrote, okay, so this would actually look like a log of 100 is equal to 2. When you see nothing here, that's an invisible 10. And then today what we're going to do is we're going to deal with something called natural log. And that's a special ln where this is log base e. So this log here has an e as its base. And this is to help us solve for exponential values. Now what's an exponential value? This idea of Euler's log, I think. So here's a number. We have this variable e, and e is a constant, and this is approximately 2.7 blah blah blah. If you find this button on your calculator, if you type e to the 1 power, or if you have your calculator, an old school calculator, you would type 1, and then you would hit the button e to the x, you will see the approximate value of 2.7, again, blah blah blah. And we'll be using this e a lot later. E is oftentimes used in chemistry, used in physics, and used in a lot of applications where we use something called a continuous growth model, where stuff is constantly growing. Stuff is constantly growing. Or maybe you're losing something, like my hairs. Constantly falling out. So exponential growth. Okay, so this idea of e, you remember it? It's almost like pi, right? Pi is approximately 3.1415927. But don't we just say 3.14? And if we really wanted super accurate, we would just use our calculator. The same thing, the idea for e here. E is 2.7, blah, blah, blah. Remember, it's not just any variable. It doesn't stand for any value in the known universe. It actually stands for only one value, 2.7, blah, blah, blah. Now, just like pi, which is used so often, isn't pi on your calculator? Yeah, right? because you use it so often, instead of having to write 3.1415999 blah blah blah, you just hit the pi button. The same thing idea here is for this constant e. So we're going to take that as it is right now. We're going to say, hey, this is another value that I might have to use, and we have a special log for it, and that's the ln button. So on your calculator, if you guys can find that nice ln button, let me see if I can pull up this calculator without triggering. And oh, let's just look at, oh, I knew I was going to get an ad. Bitcoin. Oh, here's the x. Let's hide the x. Okay, so let me clear this. You can see my e value is 2.71828. 1828. It doesn't repeat. It then switches to 45904. Whatever it is, you can see it. So if you ever need it, you can type that in your calculator. Most calculators don't just have the e button; they have something like e to the x. So if I want the e value, I hit 1, and then the exponent of is 1 of e is 2.718. Okay. Now that's natural log, and natural log is used specifically for e. Okay. So the first thing I want to make sure you guys are cool with is that how do we use natural logs? Okay, like how do we rewrite this? If I write log base 3 of 9 is equal to what? 3 to what power is 9? 3 to the second power. Circle of logs. What would I get if I type something like natural log of 9? Well, here's what you do. You go to your calculator and you type, in this case, my cheap calculator, I have to type the number first. 9 natural log is 2.197. What does 2.197 mean? If you remember, natural log is a log. Hello, natural log. Logs de natural. Okay. So what we're really saying is that this is the exponent. The exponent of e. So if I rewrite this as log base e of 9 is equal to 2.197. E to the 2.197 is equal to 9. So if we spin this around, sorry, my brain knows, is that log solve for exponents. So natural log of 9, what the hell does that mean? I'm still asking for what exponent of e, because that's the invisible base here, is equal to 9. Now let me try that on my calculator on my right. If I write e to the 2.197 circle of logs, does that equal to 9-ish, right? Because of the our round off error. We'll use this actually. We'll take this, we'll e it, and we end up with 9. If I just keep 2.197 and I e that, oops, 2.197 and I e this, we get approximately 8.9929, which is, we're trying to get close to 9, right? That's our round off error. So you want to be able to go back and forth and not freak out when we see a problem that looks like this. What if I write something like this? E to the 2.197 equals to 9. Uh-oh. Can you please write this as a log? Now, in this case, I actually did the work for you already. Write this as a log. Log base e of, what's my answer? 9 is equal to 2.197, because remember, this is my exponent. Logs always solve for exponents. If I want to write this as a special log with a base e, this can be changed to natural log of 9, 2.197. So we don't freak out about natural log. Natural log is just our log, but with a special base, our base e. Now, here is a question for you. What if I write this? E to the negative 1 is approximately 0.368. Please write this in exponent form. Oh, sorry, this is exponent form. Okay, so this exponent form, please write this as a log form. How would you write this as a log? And please use natural log. How would you write this as natural log? Go ahead, write it in that box there. So if I write natural log of what? Is it -1 or 0.368? Sometimes we're confused. So I want you instead to think of it this way in case you haven't done it yet. What do logs solve for? Logs solve for exponent. What part of this problem here is the exponent? What part of the problem here is exponent? Isn't exponent the -1? And my answer is 0.368. That's what it is. The idea to be able to switch between exponent form and log form is super important for us, and for us to be able to say, hey, logs solve for exponents. That's just what it is. This looks a little bit weird because of the e disappearing. But remember, the e is there. I just am using natural log instead. Same exact thing. Same exact thing. If I type, let's try this. If I do 0.368 natural log here with that button, see that's about -1, 0.999. Well, if I write log e, to do this with your calculator, you would just type a little e symbol. But for me, since I have a crappy calculator, I'm going to type log 0.368 divided by log base e. And let's see if we get about -1 here. Sorry, that's negative. So 0.368 log, darn it, 0.368 log, divide this by, where's my e button? E log that equals, and see that's the exact same answer that we just got. So it's just a nice short way of writing log e. Loggy, hey loggy, here boy, here loggy, here loggy. So I'm letting people in the class. Okay. So converting between exponential and log form, we want to be okay with that. Now, just a reminder, we have two which are not our regular logs. We have common logs. So if I write log 1000 this time is equal to 3, how would I rewrite this as an exponential form? And this is the part where we sometimes forget. So what's the base of this? Blank to the third power is 1000. If you try it, you can see that on my right side, I have a log base 10 here. So if I type 1000 on my calculator and hit log, that's going to be 3 because it's an invisible base 10. And please, you don't have to write the base 10 there, but it does help. To write this in exponential form is 10 to the third power equals to 1000. Right? And is that true? 10 to the third power is equal to 1000. Easy peasy. Your homework is just fill in the blank. Now, this one might be a little tricky. What if I wrote this? Log 1 over 10 is equal to -1. How would I write this in exponential form? What's the invisible base again? The base, exponent, answer. Okay? So what's the base? The exponent, and then the answer. Okay, so what's the base in this common log? Remember this is called a common log. Common log is base 10. So I'm going to write 10. Exponent here, circle of logs is -1 equals to 1 over 10. And this does, this is what we did way back a little while ago where we said negative exponents means you're not from around here, you're from the denominator. So you can flip any value with a negative exponent to the denominator. What if I give you a natural log problem? What if I say 4 is approximately natural log of 54.598? How would I write this as an exponential? This just looks confusing, but it's actually not. Why is it not? Because you're overthinking it. Because what type of base does natural log use? Natural log uses base e, so I'm going to write e here. What's the exponent? Circle of logs. Logs always solve for exponents, so that exponent has to be a 4. And the answer is actually inside the log. Okay, so our goal is to just be able to rewrite this, because being able to rewrite it and remembering it is important for us to be able to solve this and use this as a tool later on. Okay. So here are a couple of rules that we want to talk about logs now. It's that if I say log base 3 of 3, what exponent of 3 would give me 3? 1. These cancel out. It's almost like division, but it's not. Log base 5 of 5 is equal to what? 1. Okay? Because 5 to the 1 power is 5. What if I write log base 3 of 3 squared is equal to what? Oh, it's log base 3. Now, here's a new rule that we're going to develop right now. Okay, here's a new rule. Logs solve for exponents. So what exponent of 3 squared, what exponent of 3 would give you 3 squared? What exponent of 3 would give you 3 squared? What exponent of 5 will give you 5 squared? Wouldn't that just be a 2? One thing we want to know is that logs solve for exponents, but if the exponent's already there with the same base, here is a trick. So we're going to show this rule, and logs bring down exponents. Logs bring down exponents. And what I mean by that is if I write log base 3 of 3 squared, this is what happens to the 2. The 2 gets moved to the front no matter what, and we're left with 2 times log base 3 of 3. Folks, what do we say log base 3 of 3 is? 2. And this is our answer here. Same answer. If I give you log base 5 of 25, would you be okay? The answer, we know the answer is 2, right? We know the answer is 2. I get that. But I want to show you a trick about these logs. Since we know the answer already, we can write this as log base 5 of 5 squared. Hey, what happens to exponents? Logs bring down the exponents. Logs bring down the exponents. So it's 2 log 5 of 5. And that's just 2 times 1, which is 2. I get it. That's a lot of writing, but... So does this work with any exponent, or do they have to have the same base? Any exponent. If I write log base 3 of 4 squared, okay? Now, this is really saying this. 4 squared is 16, right? 4 squared is 16. If I rewrite this, it's really 3 to what exponent is equal to 16? Does 3 to an exponent give you 16? Is that possible? Now, using your calculator before, how would you just guess this answer? 3 to the exponent is 16. How would you guess this answer? You kind of wouldn't. You'd just be multiple guessing. You'd be like 3 to the 2 power, that would be 9. 3 to the 3 power is 27. So you'd be stuck. Right? You'd be between 2 and 3. Someplace in between there. Now I'm going to show you something kind of cool. We could type this as it is, but I'm going to go ahead and do some tricks that we've learned already. Exponent, where does exponent go? In the front. 2 log base 3 of 4. Exponents can move to the front. Logs always can bring down the exponents inside a problem. Now, here's what we want to look at right here. Okay. This is a calculator work because there's no way for me to get from 3 to 4. So on my calculator, I'm going to type 2. Oh, that was terrible. Here's 2 log of 4 divided by log of 3. Change the base. So we're going to go 4 log divided by 3 log. That gives me 1.25 2/6. 1, I'm going to keep a 1 and multiply this by 2, and the exponent's going to give us oops. I was not even reading my finger touches. .522. So what happens is we can use our logs to help us solve these problems, and this is 2.522. Again, I went through that a little bit a longer way. I could just did 16. So if I say 3 to this power, 3xy 2.522, we got pretty darn close to 16, of course, because of round off error. So today we're not practicing solving. I'm just showing you guys what we're going to do. You guys are going to be rewriting logs, solving logs, by first simplifying them. If I say simplify log of 3 to the 5th power, base 3, okay, what's the exponent get from 3 to all the way to 3 to the 5th? The exponent is 5, right? 5, bam. But I want you guys to do this algebraically. First, the 5 comes down. 5 log 3 of 3. And what happens when we have the same base? That goes away. This is 5 times 1, which is 5, which is our same answer here. Because when you guys see something like a natural log of e, this is the same as me saying log e of e, which is, what's e to what power is e? E to the first power. That's it. They cancel out. So the natural log of e is just 1. Now here's our general rule. If I write log base a of a, that's always 1. If it's the same number, it's always that same thing. If I write log base a to the b power, if we have exponent there, this is just b. A to the b power is ab. But to look at this a different way, if I bring down the exponent, log base a of a, that's just 1, and we're left with b also. So this is why we are able to bring down that exponent. Okay. If I give you something weird, if I give you 10 natural log of e to the 4. So how can I solve this one? Let's simplify it. Where does the exponent go inside the log? It goes to the front. Hey, there's a 10 waiting out for me. Thanks for waiting up for me. 4 times 10 is 40. What happens to natural log of e? That cancels out to become just a 1. Answer is 40. Okay, that's it for the class today. All right. Sorry, today was a short day.